Hi everyone, this is 6.4 dot products day 2. Yesterday you worked on finding the angle between the vectors. You found the dot product and then you found the magnitude and you took the inverse cosine and you found the angles. And that's what you're doing on this assignment. 25 and 27, you're doing a few more of those. The angles are written as linear combinations, but you shouldn't have any trouble. 29 is a little bit different. 29 gives you 3 points. Notice they are not they're not actual vectors. They're actual points on a coordinate plane. And they want you to find the vectors so that you can find the interior angles. So I'm not going to work the entire problem, but I am going to help you try to set this up so that you can figure it out for yourself. It's not a short problem. So for instance, if you the first thing you want to do is you want to graph the points and label them, and they've given you A, B, and C. So if you want to use graph paper, you can do that. It's not really necessary. You just have to have a general idea of where these vectors are. So say for instance, A is 1, 2, so I'm going to write that as A. B is 3, 4, so over 3 up 4. And C is 2, 5, so that's going to be about here. And you can see that if you connect the dots, you've got a triangle. And what you're asked to do is to find the angles of the triangle. So you need to find angles A, B, and C. So the first thing you need to do is you need to find the vectors. And so the vectors, you would find CA, vector CA. You would find vector CB. And then you'd find the length of vector AB, because you need those vectors to be able to find the angles in between. So that's what I would do here, is put them in component form and find the sides of your triangle. Once you have the sides of your triangle, then you have vectors, and you can find the angle between the vectors. So what you may want to do then on the rest of the problem is you may want to find the angles. I think I called this one theta and I called this one beta. But use the two vectors. So beta is between CB and AB. And so you would take those two combination vectors, you would take these two, and then you would go ahead and find them. Now, thinking about a triangle, how many angles do you have to find? Doing it the long way. Well, if you have 2 of them, right? If you have 2 of them, then you can get the third one. So you really just need to find 2. And I think I did these 2. And then once you have 2 of them, you can find the 3. But that's what you're supposed to do on this problem. So I didn't, it's the answer's in the back of your book. I think you should be able to find it easily. So that's your hint on how to do that one. Okay, and then starting with number 33, it asks you to determine if the vectors are orthogonal, parallel, or neither. Most vectors are neither, right? If you find the angle between them, the angle between them is not 90 degrees, and they're not in the same direction. Some vectors are not in the same direction. So basically orthogonal means that they are at a right angle to each other, right? They're perpendicular, and the dot product is equal to 0. If two vectors are parallel, this means that they are in the same direction, but not necessarily the same magnitude. So what this means is that if I have 2 vectors u and v, if they are parallel to each other, then one of them will be just a scalar. This is a scalar. Oh, can't spell. A scalar. K is just a scalar. Where u and v are both vectors. So these are vectors. So for instance, if I have vector 1, 2, and I multiply that by a scalar times 2, then I would get 2, 4. Well, these two vectors are in the same direction. They're the same direction to each other. I'm going to quit writing there because that is just gibberish. But they're in the same direction. So what you're doing is you've changed the magnitude with a scalar. So what it's asking on 33, 35, 37, 39 is to determine if they're orthogonal, parallel, or neither. So obviously you're going to check to see if they're orthogonal. If they're not, you're check to see if they're parallel. And if they're neither of those two things, you write neither. So that's what we're going to do here. So I'm going to do, the first thing I want to check is for orthogonal. So I'm going to take the dot product. I'm going to do u dot v. So that takes negative 12 times a half plus 30 times negative 5/4. And then add them together. So I have negative 6 plus 65 over 2, I think is what that is. Obviously not equal to 0. So that it is not orthogonal. All right, so B, I'm going to check to see if it's parallel. And so what this means, remember parallel means is that if I take a scalar times a vector, then it equals the other vector. So I'm going to take the x-coordinate and the y-coordinate separately. So I'm going to say negative 12 is equal to k times 1/2. So you notice that negative 12 is the x-coordinate in u, and 1/2 is the x-coordinate of v. And then I want to see what that equals. So I'm going to multiply both sides by 2, and I get negative 24 equals k. All right, so that's what k is for the x-coordinate. And if they're parallel, it'll be the same constant for both x and y. So we do this for the y-coordinates. We have 30 is equal to k times negative 5/4. And so when I multiply times 4/5 both sides, I get 120 over 5, or I could 5 goes into 36 times. I have negative 24 equals k. So in other words, if I do negative 24 times 1/2 negative 5/4, that's going to equal negative 1230. So these are parallel. These two are parallel. So you check for orthogonal, because the dot product's easy to do, and then you check for parallel, and then if it's not any of those, then it's neither. Okay? And so there's going to be one of each one, and then they give you one where there's a k, and you need to figure out what k is. So I hope this gets you a little further on your assignment. I'm expecting you to work hard on this so that when I get back on Wednesday, you'll be ready to go. So take care, and see you soon.